Okay, here we go. Chapter 10, Lesson 3. My goal this week, if you're watching this Sunday, it doesn't count. I'm taping it today, but this is for this coming week, Monday through Friday. I would like you guys to try to complete Chapter 10, Lessons 3, 4, and 7. I say 7 because I already taught 5 and 6. So 3 lessons this week with some practice thrown in between. Next week we'll do lesson 8, some review and some kind of an assessment to try to keep you in line with what I would have done if we're still in school. All right, so today, chapter 10, lesson 3 is actually just all about patterns. It's called special products of polynomials. So there's 2 different patterns that they're going to talk about. This section isn't something you absolutely positively have to know, but it's going to be a lot more handy when we start to factor polynomials. So when it comes to factoring, if you notice these patterns, it's going to be easier. Not necessarily the way we're doing it today, but if you memorize them, your life will be easier later. Okay, so one pattern is called the sum and difference pattern. That is just explaining that if you have 2 binomials that are factors, like 3x minus 4 and another one that is 3x plus 4, sum, adding, difference, sum and difference. One is plus, one is minus. You're going to have the exact same terms being subtracted as you are added. So these numbers here and here have to be the exact same, and this value here and here has to be the same as each other. So in order for this pattern to take place, you need, again, the same term in the beginning part of the binomial and the same term at the end. But in one set of parentheses, you will have a plus, and in the other, a minus. Yes, they can be flip-flop like it sees right here. So if you notice that you have that pattern, same 2 numbers, one subtraction, one addition, then all you need to do to multiply them together, instead of doing the distributive property twice, you can just square the first term, square the second term, and put a subtraction sign in between them. Okay, so when I say first term and second term, I'm disregarding the subtraction sign and addition sign. So I'm talking about 3x being your a value, or representing a. Okay, the 3x represents your a. And your 4, just 4, not a negative 4, just your 4 represents your b value. So look up here, right? A plus b, a minus b. And I'm supposed to take a squared, in other words, 3x squared, subtraction sign in your pattern. So subtract, and then b, which is 4 squared. So 3x, don't forget about the x part, but 3x, if you square it, meaning 3x times 3x, you're going to get 9x squared, subtraction sign, and 4 times 4 is 16. If you forget the pattern, you don't notice the pattern, you forget it, and you are supposed to find a product, that means you're just supposed to multiply it out. So like I taught you in lesson 2, if you have 3x minus 4 and 3x plus 4, and you're supposed to multiply it out, you do 3x times 3x, that's 9x squared, 3x times 4, that's 12x. Here's why those 2 cancel each other out. When you do negative 4 times 3x, you're going to get a negative 12x. So you drop that middle, the middle 2 pieces, because you're going to end up with a positive and negative, of the same thing. And then back to negative 4 times 4, which would be your negative 16. So this part right here always cancels out in the pattern. But if you forget the pattern and you just happen to have to work it all the way out, it's no big deal. Okay, so I'm saying it comes in handy when we go to factor later, but sometime if you forget the pattern or you don't notice the pattern and you just decide to use the long method of multiplying everything out, doing the distributive property twice, you will get the same result. See how this is the same as this using the pattern. Okay, again, pattern, super handy to memorize. Trying to tell you to memorize it. Okay, The other pattern is called, so this is one, sorry, pattern number 1, sum and difference pattern. Pattern number 2, square of a binomial pattern. This one isn't quite so handy. It's not as fun, I guess. Basically, you're multiplying a binomial by itself. You're squaring it. That's what they mean by square of a binomial. Binomial, 2 parts, x and 4, x plus 4. I'm squaring it. X is your a value, 4 is your b value. And then you follow this pattern. Okay, so if a is x and b is 4, I'm going to replace every a with an x and every b with a 4, and follow this pattern. So a squared, in other words, x squared, plus 2 times a times b. So 2 times x times, and my b is 4, plus, and then b squared, b is 4, so plus 4 squared. Do a little math, x squared plus this right here, it's going to be 8x plus 4 squared is 16. That would be my answer. Again, if you forget the pattern, you can literally, it's x plus 4 squared, just means you're going to do x plus 4 times x plus 4. And you can multiply it out the long way. X times x, x times 4. Well, look, another 4 times x, and 4 times 4. You see how that middle part, it says 2ab? Basically, you're going to have that 4x twice. Look how it shows up here, 4x and 4x. There's 2 of them. That's why you get 8x in the middle. Okay, so there's a pattern. It lends itself to doing things a little quicker, especially when we get to factoring. If you forget it, you can always multiply everything out and notice that you have 2 4x's, which would make 8x in the middle. So there's a square of a binomial pattern, but they give 2 examples because this is the example if you have an addition sign in your binomial, but this is the pattern if you have a subtraction sign in the binomial. Notice up here for the pattern, when there's an addition sign, you have an addition sign in the trinomial in the front and in the back. When there's a subtraction sign, look at this pattern. The subtraction sign is only in the front right here. So they don't both turn to subtraction when it's subtraction, only the one in the front. Okay, so we're going to practice putting this 2x. 2x is your a, and 6 is your b. Again, you're not messing with the subtraction sign, making the 6 a negative. But I'm going to put it into this pattern here. So a squared, and my a is 2x. I'm going to take 2x squared. Minus sign, 2 times a times b. 2 times 2x, because that's my a, times 6, that's my b, plus b squared. So plus 6 squared. 2x squared is 4x squared, minus 2 times 2 is 4 times 6 is 24, with an x times x, plus 6 squared is 36. And that should be my result. Okay, so you're going to want to just practice some of these patterns. So I find the product. You're either in square of a binomial or you have sum and difference pattern. If it's a square of a binomial, you're only going to see one binomial with a little 2 up here. This is the sum and difference pattern because you have 1 plus, 1 minus. So that sum and difference pattern, a squared minus b squared is what that looks like. Meaning my a is 3b and my b is 5. So I'm going to take 3b and square it, put a subtraction sign in the middle, and take my 5 and square it. Again, don't forget that 3b squared is literally 3b times 3b. So you're going to get 9b squared. Minus, and 5 squared is 25. Ta-da, all done. Again, it's going to come in handy when you have something like this and you have to factor it, and this will be the factored form. This is called expanded form, factored form when you see the parentheses because they're factors. Okay, so example 2 is that squaring a binomial pattern. So square of a binomial pattern, a squared plus 2ab plus b squared. Okay, a squared plus 2ab plus b squared. Maybe define what a is. A is 7a. I'm going to replace the letter A right there with a 7a. My b is 2. Every time I see a b, I'm going to replace it with a 2. A, 7a squared plus 2 times. A is 7a. B is 2. Again, b is 2, and I have to square it. This squared will be 49a squared plus multiply all the numbers. This does not have to stay together. This is literally like a2 times 7 times a times 2. So 2 times 2 is 4 times 7 is 28a plus, and then 2 squared is 4. Okay, we use this when we're working with the Punnett square. I think you learned this last year a little bit in your science classes. So the Punnett square at the right, or below actually, is an area model that shows the possible results of crossing 2 pink snapdragons. Snapdragons are flowers, by the way. You should look them up. Kind of pretty. Each with one red gene, which is the capital R, and one white gene, which is capital W. Okay, those would be like their parent plants. Show how the square of a binomial can be used to model the Punnett square. Okay, so they're saying that if this flower is pink, they have one red gene and one white gene. One red gene and one white gene. And then notice how in this corner you'd have red, red. In this corner, red, white. They're calling red, white the pink, by the way. Red, red would be all red. White, white would be all white. And this one would be another pink one. So it says each parent snapdragon has half red genes and half white genes. You can model the genetic makeup of each parent as, like, this means like 50%, right? 0.5, so half red and half white. The genetic makeup of the offspring can be modeled by the product 0.5r plus 0.5w squared. So we are just literally going to 0.5 red plus 0.5 white squared is the square of a binomial, meaning a squared plus, I put the plus sign there because this is addition, 2ab plus b squared. I keep getting off my screen. I wish I should have one of you here just to tell me you're off the screen because I can't look at the paper and look at the iPad at the same time. Okay, so my A is going to be the 0.5 capital R. Right there, that's my A. My B is going to be 0.5 W. Okay, that's my B. So A squared, 0.5 capital R, square that, plus 2 times my A is 0.5 red, times B, 0.5 white, plus B squared, which is 0.5, 50% white, squared. All right, this literally means 0.5 times R times 0.5 times R. So 0.5 times 0.5, half of a half is 0.25. R squared plus 2 times if I did left to right, I guess, 2 times 0.5 is 1, and then 1 times 0.5 is 0.5. So 0.5 R times W. Because if you want to write that all out, that does not need to stay together, right? It's like 2 times 0.5 times red times 0.5 times white. And you can multiply the 0.5 times the 0.5 times 2 and then just write RW for times red times white. I'm right here now. So 0.5W squared, 0.25W squared. Here's what this means in terms of snapdragons. You should all know that 0.25 is 1/4. So 1/4 of the flowers, 25% will be red. Red because RR, 0.25 RR, red. Right here, this would stand for 50%, or half of these flowers will be pink. This is not always 100% true. And then a fourth, 25%, should be, that's what I should say, will be white. Okay, there you go. I will post the assignment as well, I think in Google Calendar. So there you go, there's lesson 3.